Hello, my name is Veinovic. I'm assistant professor at the Faculty of Mining, Geology and Petroleum Engineering at University of Zagreb, and I'm a co-author of this invention and the improvement related to deep geological repository for spent nuclear fuel. Now, since the nuclear fuel is one of the main problems for engineers today and one of the most serious problems, there is a lot of research related to that problem. So anyhow, the way to manage spent nuclear fuel after it's being removed from the nuclear power plant is, of course, I think the best way would be deep geological disposal. Now, one of the concepts that can be used is SKB3V, which is basically disposal into the borehole from the tunnel at the depths of around 500 to 1000 meters in a specific host rock like granite or some other high quality type of rock. Spent nuclear fuel rods, of course this is a smaller version for the model, are being placed into iron insert, which gives rigidity, it makes the whole concept quite rigid, and that's first isolation. Of course it's being kept with the iron cap, and then this insert goes into the copper canister. Now this is one of the concepts that is basically the most researched in the world. So the idea is to use bentonite discs and put them at the bottom of the borehole, and then bentonite rings, which will in a way be a buffer between canister with spent nuclear fuel and host rock. So after it's being placed like this, the borehole is closed with some more bentonite discs, and usually that's it, more or less. Now, everywhere in the world, numerical modeling does just that. But the problem is that in those numerical models, one thing that is never been incorporated in the model is this part of the tunnel, and that is excavation damage zone, which is really something that happens after you excavate using drilling and blasting method. Now this zone is real, and those cracks in the rock really represent potential way for radionuclei from the spent fuel to move through the damage zone and get in contact with biosphere. Now our invention or our improvement of the model is to put also EDZ, excavation damage zone, into a numerical model, and in a such way make numerical modeling much more correct and real. So it's a really great improvement because we have proved that it's possible that radionuclei will move quite quickly through that zone after they reach the zone, and let's say that the time for transport of radionuclei to the surface would be much quicker than if we could somehow avoid to have this zone. We, of course, plan to keep on redeveloping modeling for this and other concepts of deep geological disposal of nuclear waste. Thank you.